Hello children, welcome to Right Tuition Classes. We are doing lecture number 2 of the same paper 1. Okay, we are solving paper 1, children geometry paper 1 and lecture number 2 of it. Now question number 3 onwards we start. What it says, question number 3 again, complete the following activity. Anyone, you have to complete the following activity, okay? Now first activity, when you look at it, children, first activity is very simple. When what it says is, children, it says, complete the following activity to draw tangents to a circle. Plural word is a tangents. मतलब एक से ज्यादा tangents, हमेशा ध्यान देने का. Draw tangent to the circle singular है, तो draw tangents बोलेगा तो एक से ज्यादा. Okay. Now the question says, पहला question, draw a circle. Draw a circle of radius. This question number 3. I'm doing it here. I'm just trying to show you. Question number 3, A part, question number 1. Okay. Here, I'll just show you a rough figure. I cannot draw it and show because I cannot use the instruments here. Okay. I know there are instruments to be used, but I'll have to use another software. I don't want to. Okay. I just want to keep it simple. Complete the following activity to draw tangent to a circle. Draw a circle with radius 3.3 centimeter. Imagine I've drawn a circle of radius 3.3 centimeter. Imagine a circle of radius 3.3 centimeter. Draw circle radius and center O. Okay, this is my center O. Draw chord PQ of length 6.6 centimeter. Draw chord PQ of length 6.6 centimeter. So what I'll do, children, I'll adjust the compass to radius. I'll adjust the compass to radius 6.6 centimeter. I'll adjust the compass. I hope people know what is a compass, okay? Then you take anywhere on this point as center and just cut an arc of radius 6.6. This point again as center, this point as center, again cut back an arc of 6.6. So this segment where the two arcs intersect is a chord of length 6.6 centimeter. So the question was, draw a chord QR PQ of length 6.6. So I have drawn a chord PQ. Then they say, draw a line perpendicular to ray OP. They want me to draw ray OP, children. They want me to draw ray OP. So I draw this yellow line OP. Okay, I draw this yellow line OP. Okay, this is my ray OP. This is my ray OP. Okay, I just put an arrow here. Okay, this is my ray OP, and also they want me to draw this ray OP and draw a line perpendicular to ray OP at P. I want to draw perpendicular at P. I want to draw perpendicular to ray OP at P. Perpendicular will come like this. So how will you go about, children? You take this P as center, adjust your compass to any suitable radius, cut an arc on the right hand side, cut an arc on the left hand side, same radius. Now you can see this. Take this point as center, this arc as center, radius. Suppose this I name it as X, this I name it as Y. So can you see the small xy? X as center, radius more than xp, you'll draw an arc. Y as center, same radius, draw an arc. Draw a line passing through. Draw a line passing through. Children, draw a line passing through this point of intersection of the arc and P, and that point, that line will be the tangent. That line will be the tangent, okay? This line will be the tangent. This line has to be the tangent. In the same way, children, they want you to draw a tangent at Q. So what they draw a line perpendicular to ray OQ. First step, draw ray OQ. When you draw ray OQ, you can see O as center, OQ, okay? I'm drawing ray OQ, okay? I've drawn ray OQ. So I put an arrow here, children, so that it really looks like a ray, okay? Ray OQ, okay? Now at Q, they want me to consider perpendicular. So take Q as center, adjust your compass to a suitable radius. Q has cut an arc. Some radius, cut an arc here, cut an arc on the left hand side, I said right hand side. Suppose this is x, this is y. They take x as center, radius more than x cube. Okay, more than x cube. Draw an arc. Take y as center, same radius. Draw an arc. Okay, draw a line passing through the point of intersection of this arc and your cube. And this will be the tangent. Okay, this is the second tangent. Okay, so this was just a rough figure, children. I hope people can understand it. Okay, it will just help you to remember how to construct a tangent. This is not drawn to the measurements, nothing. This is just a rough figure. Question number 3, first part of the question is over. Now I go to the second part. Second part is nothing but, children, you can clearly see this is a activity sum in the form of fill in the blanks. A bucket is in the form of a frustrum shaped. This is a frustrum. This is a frustrum. A bucket is in the form of a frustrum shape. A bucket is in the form of a frustrum shape. Okay. Bucket is in the form of frustrum. Its height is 28 centimeter. They are marked the height 28. Radius of the two circular faces are 12 centimeter and 15. Chota radius 12 centimeter hai, or bada radius 15 centimeter hai. Find the capacity of the bucket. Find the capacity of the bucket. Volume of the bucket. So always the bigger radius, we are taking it as R1, 15 centimeter. R2 is a smaller radius. How much is a smaller radius, children? R2 is, here they are giving it as 12 centimeter. R2 is 12 centimeter, children. Height is 28. Capacity of the bucket is equal to volume of the cone. Can I say volume of the frustrum? Volume of frustrum. Volume of frustrum. Okay. This is nothing but 1 upon 3 into pi into R1 square plus R2 square plus R1 R2 into H. Now that 1 upon 3 pi is 22 upon 7. This H has been written here 28, and inside the bracket R1 is 15 square, R2 is 12 square plus R1 R2 means 15 into 12. When you multiply all this, when you add this, got it, how much you get, and multiply. Cancel 188 into 183. So 88 into 188, 88, what you can do is, children, you can clearly see this calculation, this calculation. You can easily do it. 183 multiplied by 88. With 180 multiply, 8 3s are 24. 8 8s are 64 plus 2, 66. 8 1s are 8 plus 6, 14. Again, children, 4, 6, 4, 1. So when I add 4, 10, 11, 6, and 1. Are you getting me here? So it will become, what you get, children? Okay, I'll write it here. Okay, I'll put the answer in. It is 16104. 16104 centimeter cube. This divide by 1000, so 16.104 liters. 16.104 liters. 16.104 liters. You can check it out, children. I'm sure this my multiplication, I'm doing it in a hurry. Okay, you can check it yourself, children. Multiply and check it, okay? Like 88 multiplied by 183. 183. 88 multiplied by 183, you got it as 16,104. Divided by thousands, because I wanted liters, it will become 16.104 liters. Are you getting me a liters? Are you getting me a? Okay. So I don't think this is difficult, children. It was a simple sum. We go to the next sum, children. The next sum is, okay, only 2 sums are there. Now we go to the B part, okay? This is a very simple question, children, and very easy question. I'm sure everybody will be able to do it, okay? I'm sure about it. So let's see here. Okay, solve the following questions. I need 2. any two question of this three we have to solve. Okay, right. First we talk about architecture. Architecture has a model of a building. The length of the building is 1 meter. Length of the model is 0.75 centimeter. Then find the length and the height of the model building, whose actual length is 22.5 and height is, see, actual length. Please have a look here. The ratio of the length of the building, length of the actual building to the length of the model is 1 meter upon 0.75 centimeter. Okay, children? Okay. So this is my first, in this question number 3 ka, P ka, question number 1. Are you getting me here? Question number 3 ka, P ka, question number 1. What they are saying, the architecture has a model of a building. Length of the building is 1 meter, then length of the model. There's just ratio of the length of the model, ratio of the length of the building, length of building upon length of building upon length of building upon length of the model, how much I get, length of model will be equal to, children, how much this ratio is given to you as 1 meter to 0.75 centimeter. So when you try to do it, this is 100 upon 75. So this will become 25 fours are 25 threes are 4 upon 3. Okay. This is what they're giving in the first part. Architecture as a model of building. Length of the building is 1 meter. Length of the model is 0.75 centimeter. So I'm not changing the unit also. 1 meter and 0.75 centimeter. That I change it is 100 upon, when I remove the decimal. Okay, 4 upon 3 I'm going to get. Now what they're saying, find the length and height of the models when actual length is actual length L. Okay, I'm writing it here. Actual length L. I'm writing it to the right hand side, children. Actual length L is how much, children? Actual length is 22.5 meter. 22.5 meter. So length in model be L1, children. I want to find L1. Actual height of the building, H is equal to kitna, children? They're giving 10 meter. And height in model I'll take it as H1, children. Now remember, children, building and the model, building BLDG and its model are similar. Therefore, what will happen, children? Therefore, L upon L1, H upon H1 will be equal to 4 upon 3, children. So naturally, when you do it, children, how much you get? That if I substitute in place of L, I'm going to put 22.5 upon L1 is equal to, in place of H, what am I going to put? Actual height is how much, children? 10 meter. Actual height is 10 meter. 10 upon H1 is equal to 4 upon 3. Now solve these ratios and how much you get, children. So you can see here, children, I'm going to solve it in a different color. Here I'm going to solve it, okay? Please check it here. I want people to check it in this box. I'm going to solve it. In this box, I'm going to solve it, okay? In this box, I'm going to solve it. In this box, I'm going to solve it, okay? So just see the answer in this box, children. What will happen? Therefore, L1 upon L2, L upon 22.5 upon L1 is equal to 4 upon 3. So cross multiplied, L1 equal 22.5 into 3 upon 4. So how much you get? L1 equal 3 pies are 15, 22 are 66, 67 point upon 4. So this is L1 is going to be 4, 4 18s are 72. 4 16s are, no, sorry, 4 15s are 60. 4 16s are 64. Okay. 8s are 32. 3 7s are 28. So something in this. L1 equals 16 point, how much? 87 centimeter. Okay. So many centimeter length of the model. Okay, children. In the same way, when I do this H1, please have a look at this. Okay, I want even height, the actual height of the model. Okay, height of the model. So what I'm going to do, children? Height of the model, when you want, children, height of the model, you can check it out here. It will be height of the model also you want. Okay, so check it out, children. So how much you're going to get it here? See, this is 10 upon H1 is equal to 4 upon 3. So H1 equal 30 upon 4, 7.5. H1 equals 7.5 centimeter. So height of the model is 7.5 centimeter. Okay, children, I'm sure everybody understood me. A very simple question. Okay, now I go to the next question, children. The answer continued here, children. I hope everybody will understand it. Okay, I know I'm making a mess here, but I just an adjustment, children. Okay, you can see. We go to the next. We are going to the next one, children. Question number 2, children. Determine whether the given points are collinear. Now, A coordinate is 0, 2, B coordinate is minus 1, minus 0.5, and C coordinate is 2, minus 3. So, how to show whether they are collinear? Very simple, children. You'll find slope of AB first. Slope of AB. What is slope of AB, children? Slope of AB equal y2 minus y1 upon x2 minus x1. I hope people know the formula of slope. So, AB, y2 is what? Minus 0.5 minus 0.5 minus 0x, y1 is 2. The whole thing upon 1 minus 0. So when you do it, minus 0.5 minus 2, it is minus 2.5. What it is? 2.5 minus 2.5. So what is slope of AB, children? Minus 2.5. Now what I'm going to find out, slope of BC I'm going to find out. Slope of BC I'm going to find out. Slope of BC. Please look here. Slope of BC. Again, formula is y2 minus y1 upon x2 minus x minus 3 minus or minus 0.5. The whole thing upon 2 minus 1. So when I try to do minus 3 plus 0.5 upon 1. So how much you get? Minus 2.5. So don't you agree slope of AB was minus 2.5? Slope of BC is minus 2.5. Therefore, slope of slope of AB equals slope of BC. Slope of AB equals slope of BC. And B is a common point. B is a common point. AB में भी आता है, BC में भी आता है. So AB, B is a common point. Therefore, AB and BC are one and the same line. One and the same line. And if they are one and the same line, I can see that 4 points A, B, and C are collinear points. A, B, and C are collinear. I hope everybody understood me here. See here, children. Slope of B coordinate is how much? -1, minus 0.5. C coordinate 2, minus 3. So what is the slope of AB will be how much, children? You can check it. y2 minus y1 upon x2 minus x1 minus 0.5 minus 2 upon 1 minus 0, that is minus 2.5. Then children, slope of BC, okay? Slope of BC will be, you can see here, children, minus 3 minus a minus 0.1. So when you try to solve it, upon 2 minus 1. So minus 3 plus 0.5. The whole thing upon 1, that is nothing but minus 2.5. So what is the slope of AB equals slope of BC? And point B is a common point. Therefore, AB and BC are one and the same line. Therefore, points A, B, and C are collinear. Okay, children? Now, this is a very simple sum. We go to the next sum, children. We go to the next sum. A very simple proof. Okay, I'm going to do it in a very easy proof. I'm sure everybody will be able to do it. Okay, children? Very important sum, children. In two circles intersect, if two circles intersect each other at M and N, secants through M. Can you see this line is called a secant? A line which intersects the circles at 2 points is called a secant. A line through M, this is a secant. Secant through M and secant through N intersects the circles at RS and PQ. You have to prove SQ is parallel to RP. SQ is parallel to RP. Whenever you want to produce segments parallel, पहला काम उसका ट्रांसवर्सल तुम दो. देखो SQ parallel RP, SQ parallel RS, इसका ट्रांसवर्सल RS है. Now on this transversal RS, this angle 1 and this angle 3, what are they forming, children? Interior angles. If the interior angles are supplementary, then the lines are parallel. That means आपको अगर SQ parallel RP मांगता है, angle 1 plus angle 3 का measures add करके 180 मांगता है, then only I can say SQ parallel RP by interior angle test. लेकिन ये कैसा आएगा? Now remember one thing, when two lines intersect each other, this is a compulsory construction. This is a compulsory construction. This is a compulsory construction. What is that? We'll join this MN. Can you see red line, dotted lines? I'm showing it as red, okay? You'll join this MN. Now, can you see, children? I want this angle 1. Somehow I want this angle 1 plus 3, 180 I want to show. So this one is involved in this. Hey, can you see one quadrilateral, MNPR? This quadrilateral. So I'll first say construction. Construction is what, children? Draw segment MN. Draw segment MN. Okay? Draw segment MN. And now I have to write a proof. So look here, children. Quadrilateral MRPN is cyclic. Cyclic quadrilateral by definition. Therefore, angle R. Can I say angle R? Yes. At R, only one angle is there. Plus, but here at N, there are two angles. So I have to write 3-letter name. Angle R plus angle MNP is equal to 180 degree. And statement number 1, this is opposite angles of cyclic quadrilateral are supplementary. 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 Okay, children? Now, when you look at this, children, okay, I got R. I don't want this MN. I don't want this MN. Okay, this MNP, I don't want angle MNP. So again, look at this quadrilateral, children. Don't you realize this quadrilateral MNQS, MNQS S is cyclic by definition, children. All the four vertices lie on the circle. Then, children, there is one more property. Extra angle of a cyclic quadrilateral is equal to interior opposite angle. This MNP is an extra angle. It is equal to interior opposite angle. So angle MNP is equal to angle S, children. This is my statement number 2. Exterior angle of cyclic quadrilateral is equal to its interior opposite angle. Now what will happen, children? Therefore, this MNP, in place of angle MNP, I'll put S. Therefore, angle R plus angle S is equal to 180 degree from 1 and 2. From 1 and 2. But look at this R and S. Don't you agree they're interior angles? Therefore, interior angles are supplementary. That means these two lines are parallel. Therefore, segment SQ parallel segment SQ parallel segment RS by RS. See the question RS by interior angle test. By interior angle test. By interior angle test. By interior angle test. Okay, children? Now, I hope people are understood here. I somehow squeezed it, okay? Now, we go to the next question, children. Draw a circle with center and radius. Okay, very easy question. Draw a circle with center O. You can see here, children. I want to do question number 3 ka fourth question, okay? Question number 3 ka fourth question. I want to start with question number 3, fourth question, okay? Question number 3, the fourth question. What it says is, draw a circle with center O and radius 3.6. Now, I cannot draw this actual figure. I'm going to just show you a rough figure, okay? See, what I'm going to do, I'm going to first adjust my compass to radius 3.6. I'm going to draw a circle, okay? You can see here. I have drawn a circle of radius 3. Draw a circle with center O. What is the center of the circle? O, children. And what is the radius of the circle? 3.6. Draw tangent, only tangent, singular. Tangent to the circle from a point at a distance 7.2 centimeter from the center circle. Oh, there is one point which is at a distance of 7.2 centimeter from the center. So I first draw a line, okay? Then I take this, suppose this is the point, whatever that point, suppose I take that point as P, okay? Draw a tangent to the circle from point P, which is at a distance of 7. So O as center, radius 7.2 centimeter, cut an arc. What is the radius of this arc, children? I'm so sorry. It should not be like this. Only one arc should be seen. Okay. Only one arc should be seen. Okay. So that radius, how much? You cut this arc. This is your P. Okay. Now this is 7.2. How much is this? 7.2. Now what they want you to do, draw a actually tangent to the circle from a point P, which is at a distance of 7.2 centimeter from the center. So draw perpendicular bisector of this OP now. O as center, radius as more than half of OP. Draw an arc, okay? Here also. O as center, radius more than half. Draw an arc above, draw an arc below. You take P as center, same radius, draw an arc above and below. Again, draw a line passing through the point of intersection of these arcs. This line, okay, this line, children, is perpendicular bisector of OP. This line is perpendicular bisector of OP. This line is part. Now draw a circle, okay, which will pass through this, like take this M as center. Take this M as center, this point. Suppose I take this point as M, okay? I take this point as M. And I take this M as center, radius as MO. I'll cut one arc, okay? M as center, radius MO, cut one arc. M as center, radius MO, cut one arc. M as center, radius MO, cut one arc. Or complete a circle, okay? or just cut one arc, only one tangent. Then draw a segment joining your P and this arc, okay? And this is your one tangent. This is your one tangent, okay? This segment PB, so PT is a tangent. So segment PT is a required tangent, is a required tangent, is a required tangent. Okay, children? Now you can see here, children. Okay, now we will just go to the next sum, children. Okay, before I go to the next sum question, next question number 4. Question number 4, sub question 1. Okay, what it is, triangle ABC is right angled with angle A equal 90 degrees. This angle A is 90 degrees. Okay, a circle is inscribed in it. The length of the sides containing the right angle, the length of the sides containing the right angle are 6 centimeter and 8 centimeter. This side is 6 centimeter and this side is 8 centimeter. Length of the side containing the right angle is 6 centimeter and 8 centimeter. And they wanted to find the radius of the circle. So whichever, please have a look here. Again I repeat, triangle ABC is right angled at A. Triangle ABC is right angled at A. Okay, a circle is inscribed in it. Can you see a circle is touching all the three sides? Circle is inscribed in it. Ka matlab, circle is touching all the three sides. Are you getting me here? The length of the sides containing the right angle are 6 centimeter and 8 centimeter. And they wanted to find the radius of the circle. So what I do, suppose this is a figure given, okay? Here they are not given R, this point of contact, they are not mentioned. So what I'll do, let R be the, in my construction, I'm going to say, let R be the construction, okay? Let R be the, okay, I'm so sorry children, now I'll try to write it better. Let R be the point of contact of side AC with the circle and draw OP and OQ. Now, why did I draw OP and OQ, children? OP and OQ are the radii. I want to find the radius. Actually, OP and OQ are the radius. OR also you can draw, but OP and OQ, okay? Because this angle is 90. Why? What is the use of? I told you, always given information is a hint. Yeah, angle is 90 है. काय के लिए दिया angle is 90? जरा सोचो बच्चे लोग. तो अगर let the radius of the circle be solution में let the radius of the circle be r. Okay, आपको radius मांगता है. Let the radius of the circle be r. Let the radius of the circle be r. Radius of circle be r. Okay. Now tell me which segments are r then? Let the radius of circle be r. Therefore, OQ equal OQ equal r. OP equal OQ equal r. Radii of same circle. Radii of same circle. Radii of same circle. Now listen, children. Radii of same circle. Now, whenever two sides of a right angle triangle are known to us, the third side I can easily find out by Pythagoras theorem. So I'm going to use Pythagoras theorem in this triangle ABC. You can see here, children, angle B is 90 degrees given to us. Okay, angle B is 90 degrees given to us. So naturally, AC square equal AB square plus BC square. What's the reason, children? By Pythagoras theorem. By Pythagoras theorem. By Pythagoras theorem. Okay, children? Now put the values, children. AC square equal, what it will be, 6 square plus 8 square. AC square equal 36 plus 64. So AC square equal 100. So what do you get? Therefore, AC equal 10 centimeter. AC equal 10 centimeter. Now what do you do, children? But what is the use? Okay, I want the radius of circle. Doesn't matter. You want the radius of circle OP and OQ are. And why this angle is 90? See the advantage. Okay, in this quadrilateral, the remaining two angles are also 90. See, if I take this quadrilateral, in quadrilateral OPAR, okay? Angle, please have a look here, OPA equal angle OQA, OPAQ it is. OPAQ, not R, OPAQ. Angle OPA equal angle OQA equal 90 degree by tangent theorem. By tangent theorem. Now remember children, therefore, angle A equal 90 degrees is given. When three angles are 90, children, the quadrilateral is called a rectangle. Therefore, quadrilateral OPAQ is a rectangle. Okay, three angles are 90 is enough to say a quadrilateral is a rectangle. I know four angles are 90, then it's a definition, okay? But whenever three angles of a quadrilateral are right angles, you can call it as a rectangle. Now, if it is a rectangle, don't you agree the opposite sides are equal? So look here, I know it will become a square, but I don't want to waste my time. OP equal AQ equal R, got it? And OQ equal AP equal OQ equal AP equal R. Reason is opposite sides of rectangle. Opposite sides of rectangle. Opposite sides of rectangle are equal. Okay. That was the reason, children, earlier itself. The radii we had shown, okay, they're equal to R. Now look here, children. Now trying to understand what is, suppose AQ is R, AP is R. If AQ is R, what are you going to get? Don't you agree BQ I can get? BQ equal AB minus AB, the whole AB minus BQ. You can see A dash Q dash B. So BQ equal, what is AB, children? AB is 8 minus R. AB is 8 minus R. Now listen, once you know BQ, then BQ का मतलब से BQ मिलेगा BR equal BQ. BR equal BQ by theorem of tangent segments. By theorem of tangent segments. By theorem of tangent segments. So come on, tell me, what will happen, children? Therefore, BR equal 8 minus X, okay? Even BR is 8 minus X. In the same way, here also, this is R, children. If this is R, naturally, you're going to get CP here. AP is R. So what is CP? CP is going to be CP equal, just find CP, children. CP equal AC minus AP. What is the reason? A dash, P dash, C. So what is CP equal, children? This will become 6 minus R. But once I know CP, CP का मतलब से क्या मिलेगा बेटा? CP का मतलब से CR मिलेगा. But CR equal CP by theorem of tangent segments. By theorem of tangent segments. So what will happen, children? You can see therefore CR equal 6 minus R. Now try to understand, children. Again, I repeat, first what I had done, I had taken the radius as, please have a look here. I had taken the radius as R, okay? I wanted radius as R. Then I realized angle A is 90. That means this quadrilateral is going to be a rectangle. If it is a rectangle, opposite sides are equal. So naturally, OQ will be equal to AP equal R. OP will be AQ equal R. But if I know this segments, don't you agree? See what I can find. You can see AB is 8, OQ is R, AQ is R. So naturally you can find BQ. BQ will be 8 minus R. But if I know BQ, BQ का मदद से क्या मिलेगा? BQ का मदद से PR मिलेगा. वैसे ही बेटा इधर देखो पूरा AB कितना AC कितना बेटा AC 6. Part of it is R. So what you get? CP you can get. CP will be how much, children? AC minus AP. 6 minus R. But then, if I know CP, I can get with the help of it CR. Now you know BR, you know CR. BR, you know CR, you know. BR, you know CR, you know. But both of them together make BC. And BC is 10. I got it by Pythagoras theorem. Both together, sorry, what is this? I'm so sorry, children. This, I couldn't see it. So I think in my Pythagoras theorem, it should be BC square. Huh? I'm so sorry, children. Just because thoda here, BC square it should have been. BC square equal, so sorry, it should be BC square equal AB square plus AC square plus AB square. AC square plus AB square. So what will happen? BC square equal 6 square plus 8 square. So BC square equal BC square equal, how much it will become, children? You can see here, 36 plus 64. So BC equal 100, BC square equal 100. So BC equal 10. BC equal 10. Now listen, this BC, you know, but BC is made up of BR and CR. So you can see, children, now I can find this so easy, children, with this yellow one. You can see here, BC equal BR plus CR. Children, B dash R dash C, B dash R dash C. Now BC, how much I got? 10 equal. BR, how much did you get? 8 minus X. How much did I get? CR, 6 minus X. So what will happen? 10, 8 plus 6 is 14. 14 goes on the other side, minus 14 is equal to minus 2R. 2R, this is not X, 2R, R, 2R. So minus 4 equal minus 2R. So what is R equal? R equal 2. So what is the radius of the circle, children? 2 units. You'll write the answer in words. Radius of the circle is 2 units. Radius of the circle is 2 units. Okay, children? Okay. Now, please have a look here. We go to the next sum, children. Question number 4, the second part. We'll go to the next sum, question number 4, ka second part. The question number 4, the second question is out of syllabus. Children, you need not, we don't have in our present tense standard, find the equation of the lines and all, okay? So naturally, this is out of syllabus, so we are not going to do it. Out of portion, I'll say. The third question, in a circle with centers P and Q. Can you see these two circles with centers P and Q? Touch each other at R. Matlab they are touching circles, you can see they touch each other at R. Prove that a line passing through R. Can you see a line passing through R intersect the circles in points A and B respectively? Correct. Now prove that the first part of the question is AP parallel BQ. जब भी तो लाइंस पैरेलल प्रूव करना है, आज ही मैंने बताया बेटा आपको ट्रांसवर्सल ढूंढना है. Now is the transversal, you can see here, even PQ is a transversal, even ARB is this AB is a transversal. So if AB is a transversal, don't agree this two angle A and angle R are alternate angles. If these alternate angles are congruent, then only I can say AP parallel BQ. But how to show this angle A congruent to angle R? How to show angle A congruent? I want angle A congruent to angle R. I want angle A congruent to angle R. So let's try to understand. सोचो ये एंगल ए किसका साथ कॉन्ग्रेंट है? पहला एंगल ए कॉन्ग्रेंट टू एंगल आर मांगता है, तो ये एंगल ए कॉन्ग्रेंट टू एंगल बी मांगता है. सॉरी, एंगल ए कॉन्ग्रेंट टू एंगल बी मांगता है. एंगल ए कॉन्ग्रेंट टू एंगल बी मांगता है. अगर ये दोनों कॉन्ग्रेंट हो गया, ऑल्टरनेट एंगल्स आर कॉन्ग्रेंट, आई कैन से एपी पैरेलल बीक्यू. लेकिन किसका साथ कॉन्ग्रेंट है पहला देखो बेटा, प्लीज हैव अ लुक हियर. सो ये एंगल ए किसका साथ कॉन्ग्रेंट है? लुक एट एंगल ए चिल्ड्रन. Look at angle A. This angle A is congruent to which angle? So anybody who thinks, array PA equal PR, radius of same circle. So angle A equal angle PRA by isosceles triangle theorem. Here angle R I cannot say. I'll have to say 3-letter name because at R there are 4 angles. Okay, many angles are there at R. So naturally PRA. Okay. Angle A is equal to angle PRA. In the same way, when I look at B, what is BQ equal? In this triangle, again is an isosceles triangle. OB equal OR, radius of same circle. So angle B is equal to angle ORB. Now remember, children, whenever you see touching circles, this is the idea that should come to your mind first. P dash R dash Q. P dash R dash Q. Okay, but theorem of touching circles. Two circles touch each other externally, then the point of contact lies on line joining centers. That is theorem of touching circles. So naturally these three are collinear. That means whenever two straight lines intersect, vertically opposite angles formed are congruent. So naturally angle ARP should be congruent to angle BRQ, vertically opposite angles. So now you can see A is congruent to angle ARP. B is congruent to angle BRQ, but ARP and BRQ are congruent. So A congruent to B होता है बेटा. Therefore alternate angles are congruent. AP parallel BQ हो सकता है. So we'll first write this, children. I look at here this proof of the first part. Okay, let's see this proof of the first part. Okay, proof of the first part. Okay, proof. Okay, first I'll say in triangle PAR. Once I look at triangle PAR, children, what I realize, segment PA congruent segment PR. What's the reason, children? Radii of same circle. Radii of same circle. Radii of same circle. तो क्या होगा बेटा? That means ये PR isosceles triangle है, दो साइड कॉन्ग्रुएंट है. तो एंगल A आपका किसका साथ कॉन्ग्रुएंट होता है? एंगल A congruent to angle PRA. I call this as 1 by isosceles triangle theorem. By isosceles triangle theorem. Isosceles triangle theorem. By isosceles triangle theorem. Okay. Now A congruent to PRA हो गया. वैसे B किसका साथ? अरे ये ट्रायंगल देखो, इन ट्रायंगल QBR, इन ट्रायंगल QBR, इन ट्रायंगल QBR. What happens? Segment QB congruent to segment QR. What's the reason, children? QB congruent QR. Radii of same circle. Radii of same circle. Radii of same circle. Radii of same circle. Therefore, angle B is congruent to angle B is congruent to angle BRQ. BRQ. Reason is by isosceles triangle theorem. By isosceles triangle theorem. By isosceles triangle theorem. Angle PRA congruent to angle BRQ by not by vertically opposite angles. Reason, vertically opposite angles. The reason is very simple, vertically opposite angles. And this is your stated number. I can call it as 3. Now you can see here, children, what will happen, children? PRA congruent BRQ, okay? So what happens here? This is PRA, this is BRQ, PRA congruent BRQ. This, what is that in the box on the right hand side? This PRA congruent BRQ. That means from third statement, this right hand side of 1 and 2 are congruent. Therefore, can I say angle A congruent, angle B from 1, 2 and 3, from 1, 2 and 3. But these are a pair of alternate angles for PA and for AP and for segment AP and segment AP and segment BQ. Got it? So segment AP parallel segment BQ by alternate angle test. By alternate angle test. By alternate angle test. Listen, okay? So the first part got over here. The second part, they want me to prove, this is the first part that got over of this question number 3. Second part, they want me to prove APR, similar triangle BRQ. It's so simple. In triangle APR and triangle APR and triangle BQR. In triangle APR and triangle BQR, angle PAR, congruent angle QBR. What's the reason, children? Congruent angle QBR from, you can see this from 3. Sorry, PAR, congruent angle PQR, you can see from 4, this was 4th, okay? From 4th statement, okay? Then angle PRA, congruent angle BRQ, vertically opposite angles, children. Vertically opposite angles. So both these triangles are similar by triangle APR, similar triangle PQR by AA test of similarity. Now third one, children. I want to prove this angle PAR is 35. So what is angle RQB equal? angle RQB. So naturally, see, angle A equal 35. But angle B is equal to angle A from fourth statement. Therefore, angle B equal 35. Now, in triangle BQR, you can see here, children, okay, BQ equal QB equal QR. QB equal QR. Radius of same circle. That means this triangle is an isosceles triangle. Therefore, this here, I'm going to rub it off and write it on top, okay, on the top portion, okay. You can see here, on the top side, okay, I'm writing it here, above, okay. And that too with yellow I'll write, so that you can understand this, differentiate between them, okay. QB equal PR, QB equal PR, therefore angle B equal angle QRB equal 35 by isosceles triangle theorem. By isosceles triangle theorem. Now you can see here, children, when two angles are 35 degrees, how will happen the third angle? Angle BQR plus angle B plus angle QRB is equal to 180 sum of all angles of a triangle, sum of all angles of a triangle is 180 degree. Now put the values, children. So BQR plus 35 is equal to 180. So BQR equal 180 minus 70, 110 degree. Okay. So somehow I try to fit it. Okay, children, see you all in this second lecture till here only.